Alright, here's video 8. And video 8 is more of a review of pre-calculus topics. We're going to talk about functions, secants, and tangents. And we're going to tie that to some other things. And one thing we have to get straight with our heads right away is every time we have a point on the line, and this is a function f of x, because it passes the vertical line test. If I move a vertical line anywhere along, it only hits the function once at most. This is not to be confused with the horizontal line test, which states whether this is a one-to-one function. The function I drew in green is not a one-to-one function, thus you could not find the inverse of this function. So we couldn't find f negative 1 of x. If you don't recall what that is, you will soon. The big thing that I've noticed with students starting calculus is they often get very confused about plugging in values. And I would pick a value here. So I might call this value c. And that means c is x. Well, we want to realize then that this point has a c for the x value at this point and some y value, all right, which I don't know. But I'm going to erase that because I actually kind of do know it, because we know if we plug c into the function, we'll get the resulting f of c, or the y value. So the point here, and I'll call this point capital A, is c f of c. So anytime I want to show an ordered pair, I really only need the x value and need to know the function. With that said, we have to decide how we do a lot of the details with calculus. And we're interested in tangent and secant lines. Alright? So, tangent and secant lines, we have to realize that a tangent line is simply a line that grazes a single point. That would be tangent at A. A secant line goes between 2 points. If I make that A2 and I make this A1, that's a secant line because it goes point to point. We can, so if I take off all this black stuff, there we go. I'm going to pull in some level of detail now that I pre-made. And I'm going to have a couple points here. And I'm going to plot them on the axis. I have point P and Q. Right now, this is really set up to be a problem with a secant line going from P to Q. And I could find the slope of that. And that would be what we call the average rate of change. So the secant line is going to have an average. Averages are secants. And when I look at this, this line is going to have a rise over run. The rise is the y value here. The run is the value here. But you notice I have a plus h up here because instead of b, I want to think of this point as some distance a plus h to the right. And when I do this, the rise over run, I end up with a very interesting equation. I end up with this. Change in y over the change in x. And you quickly notice in the denominator of this, a minus a is going to be 0. And it just becomes h. And this gives me the secant line between 2 points every single time. This would be the slope between points P and Q on this diagram. The only difference between a secant line and a tangent line is we bring Q back, and that makes it instantaneous. We literally think about pulling this point backwards to the point where all of a sudden P moves its way here to here to here, all the way around. So eventually it's there, and we get a single line representing this. Now the problem is if you bring Q all the way back, H goes to 0. But every time you simplify this equation for a function, the H on the bottom disappears. And we will, the thing that comes up in calculus is we will have the limit as h goes to 0 in front of this. The big thing we need to understand as we start the process here is wording. And the wording is simply this. Secant lines are an average. They require 2 points that are different, P and Q. Tangent lines are instantaneous, and they happen at 1 point. And it's probably easier to show it at Q here. And that is the tangent line at Q. Again, keep these in mind when you hear these words. Remember these equations. primary